Afternoon, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to explain about the digital modulation techniques. In this particular video, I'm going to explain about what is meant by ASK. It is nothing but a amplitude shift keying, where the digital modulation is required if the digital data has to be transmitted over a medium that allows analog transmission. So digital signals are nothing but a zeros and ones which can be sent over wires using voltages. This is nothing but a digital to analog converter and analog to digital converter. Modulator and demodulator is used where a high frequency carrier signal that acts as a basics for the information signal. This kind of modification is called modulation or the shift keying, and the information signal is called as the modulated signal. A bit rate, a baud rate will be defined here. Bit rate is nothing but the number of bits per second. Baud rate is nothing but the number of signal units per second. So these are the various types of digital to analog conversion, that is ASK, FSK, PSK, and where ASK and PSK will be combinedly called as a QAM. The amplitude shifting is nothing but here in which the amplitude of the carrier wave is altered according to the modulating signal. Then this is sometimes called as the on-off keying because the carrier wave swings between zeros and ones according to the low and the high level of the input signal respectively. Here in ASK, the frequency and the phase of the carrier wave is kept constant and only the amplitude is varied according to the digitalized modulating signal. It is also referred to as a binary phase shift keying, binary amplitude shift keying, and its usual operation is associated only with two levels. However, one can have multiple levels. This is the waveform. When it is 1, the ASK modulated wave will be there. When it is 0, it won't generate any ASK modulated wave. The generation of ASK signal, where it consists of a signal generator that produces a high frequency sinusoidal waveform. The message signal in digitized form under bandpass filter. This is the carrier wave. It is being given to the binary data sequence and it is being given to the ASK waveform. The switch provided here gets open and closed according to the bits of the message signal. When the digital bits is of level high, that is 1, then the switch gets closed. This allows the carrier wave to get transmitted. As against in case of low level, that is 0, the switch gets open and restrict the carrier wave. This is the reason why the signal appears at the output in case of a high level. After this, pulse reshaping is done by the band limiting filter according to the amplitude and the phase characteristics of the signal. Then detection. In detection, will be called it as a demodulation. It is the process of recovering the original message signal from the modulated waveform. We'll be having a coherent detection and the non-coherent detection. In coherent detection, the SK waveform is given to the multiplier where the waveform and the carrier wave is being multiplied over there. Then it is given to the integrator and finally to the decision device. Based on the threshold value, the decision device demodulates the output. The combination of the two is then fed to the integrator that operates successfully according to the bit interval. The explanation of the coherent detection block diagram is over displayed there. In non-coherent detection, the coherent detection technique somewhat leads to the complex design as it needs synchronization. However, this design can be simplified by non-coherent detection that makes use of the envelope detector. Here, bandpass filter is being applied to the envelope detector block, where the envelope detector consists of the rectifier circuit and the low pass filter, and it is being given to the switch and finally to the decision device will get the output at finally. So, as it does not require a synchronized carrier, thus the method makes use of the rectifier circuit for the rectification of the signal, after which the signal is being fed to the low pass filter, the output of which is provided to the decision device that compares the signal value with the preset threshold value in a similar manner as done in the coherent detection, thus generates the equivalent output, which is the original digital bit stream. So these are the advantages, disadvantages, and applications of the amplitude shift keying. The main advantage is its generation and detection are easy, thus facilitates simple transmitter and receiver sections. The main disadvantage of is it has a poor bandwidth efficiency and it is not suitable for a high data bit rate transmission. Then it is highly susceptible to noise and other external factors. The main application is it is mainly used in optical fiber for transmitting ASK techniques. The technique was widely used in traditional telephone modems. Assessment: why ASK is called as on-off shift keying and what is mean by bit and baud rate, and mention the few applications of ASK. Thank you.